Hello, everyone. I want to warmly welcome Yoni Goldberg, the speaker of the next talk. Yoni is an independent consultant who works with Fortune 500 corporations and helps startups to skyrocket. He's fascinated by architecture of modern backends, production hardening, and test topics. He's also the author of multiple well-known best practices guides like JavaScript testing best practices, Node.js best practices, started more than 80,000 times on GitHub. Today, Yoni will tell you about bringing your component test to the next level. Enjoy the talk.
Thank you, Roman. Thank you. So excited to be here. And I want to start with a story. So before that, let me just organize something here. Okay, I'm following the chat, which is important. And I'm ready to start. So I want to start with a quick story. This was my first Audible when I was a small child. Most of you probably cannot recognize this device. It was a tape recorder, and you can put stories inside and hear. Then there is a very famous story in my country where I live, which tells about a totally green city. And it goes something like the following. Imagine me, 6 years old child, listening to this. There is a very big green city. Everything is green there, even the sun, the houses, the roads, everything. Then the green man was walking in the green city, walking to his home. And when he arrived home, he met his green wife and green children. Then he went sleeping on his green bed, dreaming green dreams. The following day was driving his, green car, you already guessed it, listening to green music, watching green flowers, and surprise, even smoking a green cigarette. Whoa, 30 years ago, it was politically correct probably to speak about cigarette in kids' stories. And then he met a blue person. He headed to the blue person and he asked him, "Hey, who are you?" And the blue person answered, I'm from a different story. And I remember as a child, I was very excited from this story. Whoa, it's two different words connecting, the blue word and the green word. Well, amazing things are about to happen. Then I told my mother, yeah, you can go on. And she told me, this is the end. And I was kind of, what? It's amazing build up. We can unify words, but she told me, no, it's over. And I was very disappointed as a child. Luckily, this year I'm working as a backend consultant doing a lot of testing projects, and I'm seeing now a very similar story happening, and the end is much better here in this testing story. And I'm referring, of course, to the two words. One of them is the developer experience word, and the second one is the production word. And these words, originally in the testing industry, very, very separated words, right? In developers, as we code, we seek developer experience, comfort, speed, but in production, it's very noisy and surprising things are happening. And so consequently, in the development world, we write mostly unit testing and doing stuff like linting that are very fast and much simpler, while in the production world, complex things and unpredicted happen, like dealing with third parties and database, message queue, things that are much slower and harder. And for this reason, these words were built separately. One of them, the blue one, was built for developers, and the red one for QA, and they were totally different words. Now, I have a concern with this traditional model, which is I, as a developer, can't really get confidence if everything I do on the blue word is so different from production. But forget about me. Even Kenneth Beck, should I say His Majesty Kenneth Beck, kind of father of TDD, said, unit test gives us predicting suitability. Sorry, I'm going to repeat this. Unit test give up predicting suitability to production and inspired confidence for being writable, fast, and specific. In other words, unit tests sacrifice the red word to be in the safe blue word. But we want confidence, right? Luckily, many things change in testing this traditional model. Now, there's no point for me going over what happened here in the last 15 years. Maybe, shall I say, one word, just one word, Docker. Docker changed everything. Now, to ramp up a mini simplified production in my machine, it's so easier. So finally, after years, these words meet together. They are now much, much closer. So there are still things that are belong to the blue world, like linting, unit test, and to the red world, like third parties, Kubernetes, stuff that are very hard to build great developer experience for. But many of the things that were hard to work with great developer experience, like API, databases, NPM, or any third-party package manager, we can now code with these things and have great developer experience. In other words, and by the way, I'm referring not to end-to-end test or some kind of exotic test. I'm referring to the canonical test that you write as you code, kind of big unit test. Now we can have all of this production stuff part of our canonical test. And this is the sweet spot. This is the place where we want to be, the balance between great developer experience and getting confidence, doing stuff as much as closer as possible to production. And this is not new. It's a big trend in testing over the past years. You probably heard about the Spotify Honeycomb or Ken Dodd's testing trophy or the testing diamond. All of them, let me go back, all of them share the similar idea. Integration test now takes the lead. It's the main testing that we write. So why do I call it component test? What is component test? Well, testing terminology is hell, and everything means three different things. So integration test can just confuse. It might be Big Bang integration test, means multiple microservices being tested together. This is too much red for me, too much noisy and slow. There are also narrow integration tests in which we just test two modules together. And this is too much blue for me because where is all the infrastructure? And there is component test, where we test our entire microservices, what we deploy to production, all of it together, including the infrastructure. And this strikes, again, a good balance in this blue-red model. Let's see a code example of what exactly is a component test. So here we have an e-commerce system. We are adding orders. And when we add a valid order, we want to see 200 response back. So at first, in the arrange phase, I'm defining a new order, maybe doing other stuff like adding necessary records to the database that are needed for the test to run. Then in the act phase, we always enter through the door of the component, like the user, the API, the message queue, not functions, rather API. And finally, we assert that the outcome is satisfactory. In our case, just 200 response. One major note here, we should treat it's a big unit test, not a small end-to-end test, in the sense that any unit test perk that you add, you want to retain here. It's everything here in the same process. And if you want test doubles, you can do it. Coverage, you get it. Change environment variables configuration, you have it. Treat it as a big unit test. This is a Java example for you coming from the JVM world. Same test, only with Java syntax. And an opportunity for me to have some water break. Cool. So everyone agree that integration tests or component tests are the next big thing. But when you try to write some, immediately you are faced with upfront very big and complex decision, like should you install the database where, in the cloud, locally? How do you instantiate multiple web server and prevent ports collision? When to see the data? Should you see the data? Use real message queue, fake one, a lot of big decision, and it's very easy to get the wrong decision and kill the experience. And for this reason, I see often teams doing it in a very, I would call it low value implementation. It usually looks like this. So a developer wants to start writing component test for this API that we have just seen. And the test looks like this. We're checking here approaching the API and checking the response. But usually these are the type of tests that you will see, very happy pass type of test. So they usually not taking the integration and the error handling and the metrics. And when the user is being asked to run them, he should read a very long README to install all the infrastructure. And after doing all of this error prone, he run the test and usually wait seconds, if not, minutes. And afterward, very often it's flaky. Some tests sometimes fail, some other times not. And the test report is a big bulk of tests. So the overall experience feels very much like end-to-end test, something that is slow, and there are great chances that the developers won't use this line of test very often like unit test. Although this approach, this kind of experience that you have just seen has power because it covers much more layers like the database, it's mostly about happy pass flows. And not only this, there is huge overhead for it. It's slower, it demands manual installation, and the overall value, in overall, there is a positive value, but it's not impressive. It's not as convenient as unit test. Luckily, there's option B, which looks more like this. So if a developer wants to run the test, new developers just join the team, run one command or click on one button in the IDE. Immediately, the entire infrastructure is being brought down, installed in his computer, and the test runs in seconds, providing him with feedback. In seconds, his machine is ready for development thanks to testing. And when looking at the test report, it's neatly organized user stories, very descriptive, telling you what a system is doing, maybe better than a README. Now, it's so fast and convenient that you might just turn it on and let it run in the background once you code. I'm referring to watch mode. So here I'm going to mistakenly create a bug in the code, and the test automatically see the pop-up on the top right corner telling me, hey, stop, you just created the bug. And everywhere, this is the nice my data access layer. So I'm going to mistakenly change some column name, or in the database, immediately see the top right corner, the test yelling at me, hey, you just made a mistake. Here is another example. We make some HTTP call. It's very hard for a compiler to realize issues here. And we remove a mandatory field that the third party expects for. And hopefully the test, as you can see, immediately tell me, hey, you have a bug. You're making an HTTP call in the wrong way. Everywhere that I'm going to touch the code, every dark and exotic corner is covered with the test. And I say everything, it's everything, even the documentation. One more example, Open API. This is the Swagger of the API. Here we document the responses of the REST API. And let's say that mistakenly I forgot some route. This route, although the code does return this code, see the test immediately telling me, hey, your documentation is obsolete. And this is the beautiful part of component tests. You can visit everywhere. In other words, if you're doing it right, then the power is much, much higher and the cost is much lower. So in overall, the value is amazing. So you want to start replacing your unit test with this big unit test and get much more coverage with almost the same perks. Okay, so you want to do option B. You're probably telling to yourself, I'm going to seek for great documentation and do it right according to best practices. But you're going to be surprised if you see search in Amazon or Udemy for integration test. Try typing in Amazon integration test or any other resource, and you get just 5 results where none of them is actually about backend integration test. If you seek unit test, you'll get 50 books only on unit test. For some reason, for integration test, the knowledge is still being built up in the industry. So it's not very easy to realize what are the best practices of doing it right. And this is what my talk is about. Touching about the best practices, how you achieve option B. Before that, a little bit about me. I'm a backend consultant. The cool part about it, I see like 20 different teams every year, a lot of technologies and use cases, which helps me to learn a lot. Then I do what I enjoy mostly is writing about it in my blog or in GitHub. My GitHub repos with best practices has more than 80,000 stars already, and it's also a great opportunity to get feedback from people, issues, and to learn from people from the entire world. My specialty is architecture and testing. At least 70% of my projects are about this. I'm also recording now a testing course, and let's discuss testing. So we're about to discuss how to do it right, how to do component test in the right way and achieve option B. And the first things that you have to take care of is how to set up the infrastructure correctly. The first question to answer is how should you host the infrastructure? And I mean the database, the message queue, all the infrastructures that you rely on. And it's always this model, this blue-red model, that can help you organize the option and find the sweet spot. So for example, how can you create a runtime for your database? Always start thinking about production. What do we do in production? Maybe we can do the same thing in testing. Well, usually we use Kubernetes or serverless, right? These are the popular options. But installing this in developer's machine is never a convenient experience. It's not there yet. Also, most of the CI vendors don't support yet Kubernetes, for example. So a unit test type of person would suggest, hey, let's use mocks. Let's mock everything. But this, again, throws us too much into the blue world, the non-realistic. We always seek the sweet spot. What provides both almost production-like conditions and also a good developer experience? In this case, the answer is clear. Docker Compose. Almost like production, not exactly, but the best we can. Great developer experience. And if you're not familiar with it, I'm going to cover it in like 15 seconds. It's one YAML file where you define your database services that you depend on. And with one command, you just run one command. It will bring everything from the cloud and install it in your machine very fast. So here, for example, I need a Postgres database, just defining one line, some more environment variable like the database user and password. Then one command, I'm running it, and it's ready for my testing. One of the cool things with Docker Compose is that I can start optimize it for testing. So I use the same engine like production, but can start do things like this. Change the debug level to 0, so we don't need logging for testing. And we can change flag like fsync, which tells the database, hey, I don't care if you lose data, it's just testing. Don't really save to disk immediately. This will gain you, again, additional 20% and many, many, many more flags that you can put specifically for testing. One very specific test is specific flag here is the temporary file system, which allows you to store all the data in memory in a RAM folder. So this will achieve additional 10% improvement, and at the cost of maybe losing data. Who cares about losing test data? My point here is that if you just spend some time, you can use the same database engine and get even better testing perks with few optimizations. So, okay, we use Docker Compose, but where should we exactly start it? We should bring it up before we do the testing. Also here, it's the same consideration. We want to achieve the best user experience. So option one is manually. We craft a long README and ask the developer, hey, read it and do it. But then it's error prone and you just start getting Slack messages, hey, it's not working, and the developer, and someone answers, hey, you forgot to configure something. We don't want this. We want automation. We want seamless experience. Option two is a script. You provide a bash or npm script, something that will take Docker Compose up, check that the database is up, and so on. Better option, automated, but there are chances that the developer would forget this or just run the test without executing this script. For example, consider this. Someone clicks on the IDE to run the test. He forgot to run the script. no infrastructure. This is why we have option 3. We want to have the infrastructure start as part of the testing framework, as a hook. Here is a Java example, a rule, Java rule, that is calling, is using very famous that Java library test containers, and it will start it as part of the testing. So in other words, we cannot start testing without this infrastructure being brought up. In JavaScript, for example, in Jest, we can define with JavaScript file has the installation code, and anytime someone invokes the test, the infrastructure must start with it. So don't think, a very important best practice, if a developers want to run testing, one command, everything is there. Okay, so what exactly should be in this startup code? Typically, only 3 simple steps. First, Docker Compose app. In all the languages, you'll find the libraries that will achieve it, that will provide you with this syntax instead of running bash script. Then checking that the database is alive. And finally, do migration to provide the database, the schema of your database. One thing to take into account, this thing is going to be run anytime you run the test. So you don't want on every line change or every minute to take all the infrastructure down and up again. So what you can do is always keep it alive in developer machine. And one line of code before you start these instructions, check if the database is already listening. If it is, there's no need to do anything. It's already alive. And this by itself will reduce the startup time from 1 second to 3 milliseconds. Spend sometimes hours or day on these very simple optimizations to build a great developer experience for your team. Other considerations, I'm going to skip this. Okay, so we got the setup right. We get everything installed correctly, starting fast. The next challenge that you're likely to meet, which doesn't exist in unit test, is dealing with database. And what do I mean by this? Let's see a few challenges. The first one is a test, by definition, share the same database and step on each other's toes. Let's see example. We have 3 routes: post, get, and delete. Typical, right? If we look at the post route, we just add here a new valid order. As we have seen before, we define the payload, then approach the API, save the new order, and check the response. Well, what can possibly go wrong? Simple, right? Then the get route, want to check that the query works, but we're doing a trick here. Instead of, see, the arrange phase is empty. We rely on the existence of orders from the previous test. Remember the one that we've just seen, the post. And we try to query and see if we can get back this order in result. In other words, we use records that were added in other tests. What do you think on this technique? Do you like it? Well, there are 3 main major issues when you're doing such thing, which is quite popular. The first one is mystery. So you get this test failing, and you see that when we try to get all, we expect to get 10 records, but we get 139. What? So you look inside the test, and you see that, well, we expect 10 records, but look at the test inside. I mean, why 10? What implies that it should be 10? In other words, we have a mystery here. It's called the mystery visitor anti-pattern. Nothing in the test itself explains why the results should be so. Well, in reality, the developers probably counted all the tests before and noticed that it should be 139 records. Mystery, very vague, right? Concern number 2 is that, see the test now, this is a get test, everything passed. And I don't change even one single line of code. All tests pass for now. I'm only just going to execute this test alone. Test.only means I'm running one test. I want to focus on it. suddenly the test failed, although I didn't change anything. And the reason, of course, is because this test relies on other tests, but since they were not executed, it fails. We don't want the test, we don't want to rely on test execution order. This is called the domino effect. No, this is very cumbersome. But my main concern is this. So I want to add here a new test. When updating an order, it shouldn't be possible. So ideally, I would just want to focus on my test, 7 lines of code. But since we reuse data across tests, I have to read the 50 tests above me and below to understand from whom am I affected and whom I'm going to affect. Very cumbersome. Tests become from a 7 lines problem to 50 test spaghetti of dependencies. So it's a big no-no. And the solution is, of course, that in the arrange phase of every test, we create the expected state. In this example, if I want to query for existing order, in the arrange, I'm going to add the order and then query for it. Yes, a lot of repetitions, but no worries, you can use an helper, and performance-wise, I checked, it adds approximately less than 1 second to the overall execution result. So a best practice, each test acts on its own records. One should be able to understand failure only by reading 7, 10 lines of code, nothing else, not the entire file. Next challenge is cleaning up, which surprisingly is going to change the way that you write tests. Let me show you. So we have this column, this field in the API that is called external identifier. And in the database, it is unique. It has unique constraints, must have a unique value. So when I run the test for the first time, it passed. But second time, we do not change anything, it fails. Why? Well, this value 105 already exists, and the database raises an error. So what can we do? The first gut of most developers is clean up the database after every test or before. So we go to the before each or after each hook, and we clean up, delete all the tables from the database. And this will solve the problems. Now you can run the test and they will pass again and again. Not only this, we can now run a new style of test that wouldn't be possible otherwise. This one, for example, when querying for all the orders, then we want to ensure that we get all of them back. So what we do, we add exactly 2 orders. Then we approach get all API and check that exactly 2 were returned. How do we know that it's 2? Because we know that the tables are empty once we start, and we added specifically 2. Without cleaning up, this wouldn't be possible. So it seems like cleaning up before every test is the right approach, correct? Well, maybe. There is a big and interesting debate in the testing industry whether you should clean up after each or don't clean up. Let's compare the options. This is a very fundamental decision for a great component test. So we have 3 options. Transactions, which I want to skip for now. Cleaning before each, which means we purge the tables before every test, and after all, or daily, or never. In other words, once a test starts, the database has already records inside. So if we compare unique columns, we've seen that cleanup will make our life easier. Data coupling, very serious concern. If we don't clean up, developers might start reusing records among tests, which will lead to the spaghetti that we have seen. So in this sense, before cleaning up is better. What about performance? Well, not cleaning up is better because we don't have to approach all the tables before every test, but the difference is neglectable. I measured and it's approximately 800 milliseconds. So for now, it seems like the big winner is cleaning up before or after every test, correct? Well, wait with this conclusion. It's not a knockout yet. Let's see other consideration. So just a reminder, most of the modern test runners are multi-process, which means that different test suites will run in different processes simultaneously. And the following thing will happen for sure. Test number one starts at some process and it's adding 3 records to the database. At the same time, test number 20 or 30 starts at a different process and adds also its own data to the database. Then test 1 just finished and is cleaning up the tables, all the records from the database. Test 20, however, is still running. And at some point, test 20 is going to approach the database through the API, of course, and want to assert that some records are at a specific state. But the database is empty. Test number 1 deleted everything, so test 20 fails. In other words, if you cleaning up after test fails in a multi-process mode, it's very hard to configure it for multi-process work, which is a serious limitation. By the way, it's not a limitation, it is possible, but you have to sweat much more and craft a more complex infrastructure. One more concern is troubleshooting. Say that your test just fails and you don't understand why. So you want to access the database and see what are the records there and what is the relation between the records. But the database is empty, right? We cleaned up after every test, so there's nothing there. So it's much harder to troubleshoot when you clean up all the tests. Now, if you want to avoid cleaning up or clean up in the end, it's not that hard to deal with the unique value challenge. What you should do if you're not cleaning up is just add a bit of randomness, a timestamp to the unique value, and it just works without cleaning up. Believe me, I tried it in dozens of projects, it works. So there is a workaround for the non-cleaning up option. Back to the comparison table, we see that regarding troubleshooting, we prefer not to clean up the data. And regarding multiprocess, it's also better if you don't clean up the data. And there is one more consideration. That blue-red model, if you don't clean up, it resembles more production. There are more chances of finding bugs when there are many records in the database. Say, for example, think about stuff like if you have, for example, a pager will usually work when there are no records, but if you have 200 or 1,000 records in the database, there are more chances of finding stuff. So what should you do? The red, green model. Well, both options are good. I've seen great teams using both. One of them leans more toward the blue area, the clean-up option, because all the test starts with a clean slate. It's more predictable and it's better developer experience. I, though, prefer the one that is closer to the red option. Mostly if I work with a disciplined team where I know that they won't share data among tests, I prefer to be closer to the production and to the more realistic scenario. But both options are good, and at least you're aware of the consequences. Next challenge. What we've done by now is isolating each test records, which is good, it's important, but it also brings another class of bugs. Let me show you. This code created a serious production bug for my customer. Can you spot the issue here? It is MongoDB, a function that tries to update the database. Well, look here. The first parameter in Mongo is which user specifically do you want to update? And mistakenly, the ID was moved right. And all the users in the entire database were updated based on a single API call. It was a disaster there. So how can we do better? Let's see an example in our code. Here is a test that when we delete an existing order, we want to ensure that it's not retrievable anymore. It does not exist. So as we've been taught, we add the new order to the database first. Then we delete the just added order. Finally, in the search, we want to verify that the API response was positive. But very important tip here, most of the developers just check the API response. If you try to delete and get back a valid response, it doesn't mean that the operation succeeded. Always remember to check the after state, the new state of the system after the operation. So what we do here is we approach with the get API route and try to fetch the order that is presumably deleted, and hopefully expect that it's 404 does not exist because it was deleted. All great, and this test pass feels good enough. All test pass. Now I'm going to do something interesting. This is the data access code that is deleting the record, and I'm going to change it in a way that is now going to delete all the records in the system. Will our test catch this? Let's see. Will the test fail? Remember, we don't delete just one record, we delete the entire database. So let's run the test again. And hopefully my test will be able to tell me that the delete operation just doesn't work correctly. And sadly, the test passed. In other words, when we are overdoing, when we are deleting too much from the database, this is not being caught. So, just a second, I missed some, there are some slides that I think that I mistakenly deleted before. I will describe the solution verbally. Very nice trick. What you should do is, instead of adding one order, add two in that test. Or you know what, I'm going to, I don't have VS Code open. Okay, so you add two records, and then you delete one of them, only one of them. And in the expect phase, you check that one of them is indeed deleted, but the second not. In this way, using API only, you're able to check for overdoing, check that your data access code is not doing too much and ruining the system. So this line of thinking is a bit different from that unit test approach that we are used to, and something that we should build up as we move more toward component tests. We touched briefly on testing the databases and the responses, but there are many other things to test and consider. Actually, any outcome, anything that goes outside of the box should be tested. Like, for example, integrations. When we call outside, we affect the user, SMS, email, and we want to ensure not only that this request was issued, whether it was issued correctly and aligned with our third-party vendors. It's a fascinating topic to learn about and explore in the world of component test. Message queues. When we put a message in a queue, or when we start with a message queue, it's a different word of testing that we should that has its own best practices. Observability. There is another user that you should consider, the ops user. How you're doing logic and logging and metrics is very important, and also a line of tests that should be considered. This is the definition of done for you. When you're doing component test, you should consider 5 areas, 5 islands: the response, the state database, outside calls, integrations, message queue, and observability. Remember, anything you check, any feature, you should consider all of these 5 islands and ask yourself, did I cover this? Did I cover that? So usually in my longer workshop, I cover all of these islands. Today we have just touched on the database area as an example. As many other things to learn, like contract testing and testing cron job and serverless and CI and more. But wherever you're going to go in this journey, remember this model. Most of the big decisions that you're going to take are going to be based on this. Find the sweet spot, the things that tick both boxes. It is both realistic and resemble production to an extent, but it is both with great experience. And this is, my friend, the art of component test. Achieving the good from both worlds. This way you can write less tests because you don't have to check every function. The tests are much more convenient to write than end-to-end tests. You are going to cover much more bugs because it allows you to cover much more layers. So in overall, it's a new world of testing that brings a lot of opportunities. Thank you very much. Feel free to visit testjavascript.com, where I offer my online course and workshop, or my Twitter, Goldberg Yoni. I'm here for your question. It was my pleasure to be here with you today.
Thank you very much, Yoni, for your insightful talk. We have a couple of questions, so let's start with the first one by Sergey. How to clean up after tests if infrastructure does not allow to have databases separated from developers?
Roman, can you repeat this, please?
How to clean up after tests if infrastructure does not allow to have databases separated from developers?
Sure. So if I get it right, actually, is there any chance that you paste this question in the chat? I want to ensure that I get.
You can go to the Q&A tab on the right.
Oh, yeah. I was looking at the chat. Okay, how to clean up after test if infrastructure does not allow to have database separated from developers? Let me think about this one. I'm going to revisit it in a second. Shall we move to the second one once I'm building my thoughts?
Okay, that's a nice idea. Another question by Denise. What about cleaning only the data your test has created?
Oh, absolutely. I mean, what we clean up, usually in component test, we separate into multiple classes of data. There is metadata, things that usually does not affected by the test. Think about countries table, currencies, stuff like this. And there is the test data. What we clean up is only the test data. There's no point in cleaning up, metadata and other supporting database tables. So absolutely makes sense to me.
Thank you. Let's move to the next question by Daniel. Nice idea to start a Docker as a hook or precondition of your test. However, if this Docker takes 5 minutes, is there a better way?
Okay, so let me share some specific numbers here. The first time that you are going to run it, the developer, usually the first day of a developer at work, right? It's going to fetch all the images from the cloud, and it's going indeed to take 5 minutes, if not 10. But then as you develop, the second time it's going to start up in few milliseconds. If only you make these so simple optimizations that I've shown. Don't take down Docker Compose once the tests are done. Leave it up. And once you start the test, check if the database port is listening. Do nothing. 3 milliseconds measured, and your test and the setup phase is done. In CI, you don't do it, but in CI, you usually don't care that it will start in few minutes. And CI also is able to cache the images, so it won't be 5 minutes. It's going to be probably 30 seconds startup.
Thank you. Do you still want to return the question about separated, or better say, unseparated database for tests and development?
Yeah. So I see another question about contract testing also.
It seems like this question was during your talk.
Mm-hmm. So anyway, I assume that the question is, should we do contract testing? What is contract testing? Very briefly, contract testing means the provider of API, whether it's you or your collaborator, the consumer of an API, creates some documents that describes its expectations. When I approach this route, I want to get back that route. And then the provider, the one that coded the API, takes this document and run it as part of his tests to ensure that he meets the client expectations. Now, I like this approach a lot, and I think that it should be considered part of good component test. Why? Because this way we can test the expectation of both parties without spinning up. Well, what is the main problem of end-to-end test? we need to spin up many processes. Some of them belongs to different vendors. I don't know how to install their environment. Contract testing allows me to stay in the same style of development, one process, my code, no HTTP codes going outside, super performant, and still cover the line of bug that belongs to misunderstanding between two parties. There is one downside though. It's not the tooling and the knowledge in the industry, it's not mature enough. But the idea is great, and I think it's part of the DNA of component. So I hope it answered this one.
Great, thank you.
You want me to relate to the first question now?
Well, if it would not take a lot of time, because we already out of time.
Okay. So I just didn't get it right in the first time. So how to clean up after test if infrastructure does not allow to have databases separated from developers. So assuming that I got it right, there are two scenarios. One, usually we want the test to run locally in your Docker Compose. It's very important design decision. In this sense, if this is the case, you have all the permissions in the world. If you are sharing databases outside developers' machine, cloud, stuff like this, it's a world of pain and slowness. So I don't have a cure if you take that design path.
Great. Thank you very much. Thank you, everyone, for your questions. You have 3 minutes to go to the next talk. Thank you.
Thank you very much. It was a pleasure.